All right, we're back. We're going to do Techmath1. We're going to do the notes for 1.12 and 1.13. Sorry, I had to break the video into two parts because I had an interrupting, barking dog. All right, so 114. This is on page, what page are we on here? 43 of the blue book. Number 114, they want us to write 10 divided by a number x. Divided by a number. Oh, I guess I just picked x. So you could pick any letter you want unless they tell you. Oh no, it says use x as a variable. Okay, so I guess you can't use any letter that you want. Quotient of a number and 5 and that's A, that's B, this is C, is the quotient of 5 and a number. All right, so let's do it. 10 divided by a number would be 10 over x. This is fine. If you actually did the divided by sign, also fine. So 10 divided by a number or 10 over x. The quotient of a number and 5, so that would be x over 5. When you see the word quotient, whatever order it's in, that's the order that you write it. So that's fine, or if you wanted to do the old divided by sign, that's fine, either one. Quotient of 5 and a number, that's going to be divided by x, 5 over x, or 5 divided by x. These are not interchangeable. Those are two different things on B and C. Those are completely different, all right? So 118, it says 20 decreased by double a number. I want to jump to 116. Let me read it again. 20 decreased by double a number. So decreased by means that you subtract it off. So 20 decreased by is a subtraction sign, and then double a number is 2x. Careful on that. Sometimes students do x squared. That isn't double a number. That's a number squared, or a number times itself. Let's see. The sum of triple a number and 5. The sum of triple a number and 5. This is 3x plus 5. Or 5 plus 3x. When it's addition, order doesn't matter. When it is subtraction, order totally matters. All right? C, 7 more than 8 times the square of a number. So that's weird when they say it like that, the square of a number. You could say it easier by saying the number squared. But they're saying the square of a number. I don't know why. That is not to be confused with square root. That's different. So 7 more than 8 times the square of a number. So 8x squared plus 7, or 7 plus 8x squared. It doesn't matter which one you write first when it's addition or multiplication. All right? And then the last one, 50 reduced by the product of 4 and the cube of a number. So 50 reduced by is subtracted. So 50 minus the product of, product means times, 4 and the cube of a number. So 4x cubed. So right now, if you worked ahead and did the problem 116, if you wrote down 4x cubed minus 50, scratch that out. That would be wrong. You have to have the 50 first and the minus 4x to the third second. So when it comes to subtraction and actually division, order totally matters. When it comes to addition or multiplication, order does not matter which one you write first or second. All right. And then let's do one more like this. We're reading them off. 119 on 1.12. So I've kind of cherry-picked these problems to kind of match with the homework and the tests. So these are good examples of what you're going to see both in the homework worksheets and then again on the reviews and the tests. Okay. And those you have to really, the tests, remember, you got to do good on the tests. 119. All right, so 119. The sum of two numbers minus 5. The sum of two numbers. So this time it says use the letters x and y. Translate these. So the sum of two numbers, so that's going to be x plus y, and then just minus 5. They just wrote the word minus, which is easy to translate then. The sum means plus, and then literally they put minus 5. So that was a little easier to translate than the other ones. 6 more than the difference of the two numbers. 6 more than the difference of the two numbers. So that means x minus y is the difference of the two numbers, and then plus 6. Now here, because of the plus 6, you could say 6 plus x minus y, or you could say x minus y plus 6. And I guess officially, they don't really say which one should come first or which one could come second. So I would give you credit if you had y minus x plus 6 also for that one. Alrighty, let's look at C. The product of two numbers plus 1. And so they literally, product of two numbers plus 1. They wrote the word plus out, so that was super easy to translate. When they write out minus or they write out plus, that might be the easiest one to translate. And then xy, when there's nothing in between, that means multiply. If you wrote yx, that's fine. If you put a dot in between it, that's fine. If you put one of them in parentheses, that's fine. If you put both of them in parentheses, that's fine. Any of those are fine. We're lazy in math, so we really try to write the least amount of symbols that we can. So that's likely how you would see it in most math books. Triple the product of the two numbers. Triple the product of the two numbers. So product of the two numbers means x, y, and then triple just means take your times 3. So triple x, y. All right, let's look at 113. Evaluating formulas, and we want to do a couple of problems there. We'll do 4 problems out of this section. So 1.13. is what we're up to. And so let's look at 124 on page 46. This is x plus 1 over y minus 1, but then they tell you they want you to put x equals 9 and y equals 3. Okay, so just plug and chug, just plug in the numbers, chug out an answer. 9 plus 1 and 3 minus 1. Again, that's Professor Enstead, Whitewater, coined, well, or I don't know that he coined it. That's who I heard it from. He could have heard it from a professor 100 years ago. I don't know. But plug and chug, he thought it was funny. Instead of substituting the values and evaluate the expression, that's the correct mathematical terminology. Plug and chug, he said, oh, it kind of sounds like a drinking game. And so then, look at that, math is fun. So 10 over 2 is 5. Let's look at 128. We got 2y squared minus y plus 1. When y is equal to negative 1/3, the F word, fractions. So we're going to do 2 times negative 1/3 quantity squared minus negative 1/3 plus 1. So note, we put the negative 1/3 where there was a y and where there was a y. I automatically put it in parentheses when it's got a power on it. Whether it's a squared or a cubed or a fourth power, you automatically, if you're going to insert where a variable was with a number, make sure you put the parentheses on it because that should affect the negative, all right? So what is negative 1/3 times negative 1/3? Let's think of that. Negative 1/3 times negative 1/3, top times top, 1, bottom times bottom, 9. So that's 2 over 1 times 1 over 9, that's what's going on there, minus, actually plus, right? 1/3 plus 1. All right, so what do I got going here? 2/9 plus, now if I'm going to add up fractions, I need a common denominator between 9 and 3 and 1. So that's going to be a 9. And now I work backwards. I go back up to this one and say, okay, I can multiply any number by 1 and get the same number out. 1 times 17, 17. 1 times -53, -53. So if I take a fancy one, like 3/3, and multiply it by this fraction, this will be equal. It'll be equivalent. So 3/9 is the same as 1/3 because I took 3/3, a fancy one, and multiplied it by 1/3. Now, why did I do that? Well, I want to get 9 on the bottom. So I had to multiply top and bottom by the same thing. This one, I have 1 on the bottom, I want a 9 on the bottom, so I multiply the bottom by 9, and then I multiply the top by the same thing, 9/9. Which is 1. All right, so now the 9 stays on the bottom, and I add 2, plus 3 is 5, plus 9 is 14. 14/9. Oh, see, fractions, that's why a lot of people hate them, because it makes for a lot more work. Now, not all problems have to be that difficult. Let's look at the next one, 129. That one is almost basically done for us. We have v times t, that's 300 times 10. And so when we're talking about distance traveled, average velocity times time traveled, so 300 times 10, that would be 3,000 kilometers. 3,000 K. All right. And then one last problem, and then this video, she will be done. All of chapter 1. Yay, chapter 1. 132. Let's do that on page 48. That is, they have A is equal to B over B plus 1. A is equal to B over B plus 1. And they want B to be 99 red balloons. 99 over 99 plus 1, that is 99 1/100ths. Okie dokie. Oh wait, I did part B. Oh wait, they wanted it in decimal form. Shoot. So that's 0.99. And then I thought part A was just an example. We could do a quick peek at part A. Did it out of order. So instead of 99 100ths as a fraction, they wanted it as a decimal, so 0.99. But let's take a look at part A. That was actually part B of 132. Part A, I thought that was all just an example. It is not. S is equal to 1/2 GT squared. S is equal to 1/2 times G they said was 32. T they said was 3. And then squared. Okay. So let's take a look. We got S is equal to, remember when we multiply fractions, top times top, bottom times bottom, so it's 32. Oh, wait. I shouldn't do that first, though. I should do exponents first. So 1/2 times 32 times 9. Now let's go 1/2 times 32 over 1 times 9 over 1. And I could cancel it. I could take the 2 into 32 16 times, and then 16 times 9 is 144. Now, you could have also done 1 times 32 times 9 and got 288, and then divided that by 2 and got 144 that way. So it really doesn't matter where you divide the 2 into it. Multiply across the top and then divide by the bottom. But I ended up canceling, so that's just you get to work with slightly smaller numbers by doing the canceling thing. All right, so that is chapter 1 in a nutshell. Make sure to email me if you have any questions.